All right. Hey, everyone. I'm Roneil. I'm one of the co-founders of Audius. We're a decentralized audio hosting streaming protocol. So you might ask, why are we here? So this is a storage summit, not a DApp summit. The reason is, I think we have kind of a cool use case for IPFS, and I'm going to kind of walk you through how that works and a little bit more of some of the finer grain tuning that you might need to do to get IPFS to actually kind of perform well with low latency for an end user facing use case. So yeah, just to start off quickly, just wanted to give you all a little bit of context for what Audius is. So it's effectively a way for artists to connect with and distribute content directly to their fans. Think decentralized SoundCloud. It's the simplest way to put it. It's glossing over a lot of detail, but I think that's all you need to kind of get it right now. The reason we build this, or we believe the world needs this, is that right now artists get paid far, far less as a percentage of the overall revenue they're arguably creating than almost any other type of profession. To compare it to athletes, for example, football players in the NFL earn about 55% of the revenue that league generates. Musicians earn about 12% of overall music industry revenue. So here's how we actually use IPFS. Effectively, one of the misconceptions a lot of folks have with IPFS is that this is a storage system. It's not really. It's like a routing layer and addressing layer. So you still have to provide the servers, your protocol or network does. However, IPFS gives us a really neat way to reference content consistently across all of our services. So you can always know that the piece of content that you're fetching is the correct content. One of the things that's really tough, though, about working with IPFS is that it has very, very high latency. And there are ways to get around this if you kind of add more servers and whatnot, but that sort of takes away from some of the benefits of this, which are to be decentralized, right? If you centralize the hosting of all of this on some super great nodes running on AWS or something like that, kind of defeating some of the point of it. At least we would posit. So one of the things that you deal with here, for audio, our use case, the amount of data you actually need to transfer is pretty small, right? Compressed audio, if you have about 100 kbps or so of throughput, you can stream audio in real time. That's fine. So for us, latency is massively the dominant factor in fetching content rather than throughput. But there are some ways around this. So you can structure your client to kind of paper over a lot of these issues, and that's kind of what we've done at Audius to make this DApp feel and behave the same way as a normal app. So I can kind of run through these piecemeal, but the biggest one for us, or the biggest thing that improved kind of responsiveness for our users, was just prefetching very aggressively. So when you combine that with segmented data, which in our case we segment audio streams into 5-second chunks, and we use something called HLS to enable gapless playback, you can just fetch the first chunk of any song such that when a user hits play, it starts playing immediately, and that gives the client time to then go fetch the rest of the tracks. You can also failing all of these things, if you can have a way to fall back to a direct fetch, that can paper over a lot of issues. In our system, this happens, in our observation, about 1 to 1.5% of IPFS requests. The threshold we set there was about 2.5 seconds. So if it takes more than 2.5 seconds to fetch a segment, we have a way to look up which node, back here, which creator node or content service specifically hosts a piece of content. You can fetch it from there. The reason we don't do that all the time is that you're bypassing a number of mechanisms by doing that sort of, if everyone were to do that, it would not be scalable. If there's a percentage of requests going via that mechanism, things work. I can get into more of the details on that afterwards if anyone is curious. And then node configuration is the other side here. So we've set the constraint for ourselves or for our node operators, our third-party node operators, that we don't expect you to have an IPFS cluster. That's typically the way that people can increase availability. What we can do is effectively recreate our own form of a cluster by having the service providers actually explicitly peer with one another. So if they're like in Audius, right now we have like 15 service providers. If you have 15 different folks with 15 different IPFS nodes, if you know who the other nodes are, you can explicitly peer with them. You can effectively create like a subgraph within IPFS that's highly connected of all the folks that are likely to be fetching content from one another. So that's helped us a lot. And then the last one is very, very simple. But the more memory you have on the IPFS machine, the more open connections it can maintain, which will generally help with availability. So if you can set the memory requirement higher for folks operating IPFS nodes on your behalf, that helps things a lot. So yeah, that's kind of it. Always excited to share notes with other folks actually using IPFS in production. So find me afterwards if you want to chat about that. We're launching Audius in like 5 or 6 weeks. If any of you are actually interested in operating a node, come find me as well. There's an incentive program that can kind of make that interesting. And yeah, that's about it. Thank you.